Hello, my name is Ananth Iyer. I'm a faculty member at Krannert. And I'm here to talk to you about manufacturing productivity, and more specifically talk about projects that we're engaging in to understand this value. My goal in this talk is to give you a sense of things that we're learning already, opportunities I see, and with all of the entrepreneurs out here, maybe we can have a conversation, and more as we go along the way, also how we can train our students to be thinking along these lines. So the question I want to sort of think about, and John Anakin mentioned it earlier, and is that there's been a lot of claims that the deployment of smart tools can have a significant productivity value. So one of the things I'm looking for is, what is that productivity value? How do I find instances of it? And at least the only way I can repeat claims other people make is if I can actually document them and actually tangibly measure all of them. So that's the general idea. What I'm going to be a little flexible is in the title of this seminar. When I think of the word Internet of Things, I'm a little technology agnostic. So you'll see me floating around in terms of the specifics of the technology. So I'm going to talk about a few examples. And in each of these examples, I'm going to walk you through where the opportunity is, what we're trying to do, a little bit about what the technology is, and how we can measure value. Now, before I begin, I must say that I'm sitting in a business school, so we're not developing the technology. We're specifically focused on deploying it and measuring the business value. So we're at the end at which we're trying to convince a company on what is the estimate and what can you expect to happen, and we're relying on students in engineering and everybody else to sort of create the sort of the use case. This is also time for a little plug for somebody from the academic world. What we look for and where real value comes is when students see a tangible example where they're actually doing something rather than just hearing about it. So I'm going to give you some examples. And these examples will range from some video analytics tools and how we're using it, something about supplier contract, customer sensing, anticipating and learning from customer input. I'm going to give you a specific example on proactive maintenance that builds on the Whirlpool example, something along the lines of augmented reality for order picking, etc. And the very last project which I'll tell you about when we reach that point. So I want to get to, I'm hoping that this works. So let's see if, oh, it doesn't. Okay. So this one here? Okay. Okay. Ah, okay. Okay. So this was all orchestrated, you know. Okay. Okay, so what am I going to do here? Just press this button here? Okay. Okay, you got it for me. Okay. Can you click play? Okay, so this video is a data feed from a manufacturing facility. And if you look closely, you see these little rectangles appearing. And the rectangles are appearing on people, and rectangles are appearing on sheets. Okay. Now, you might say, so why are you showing me this video? First, there's a small company that allowed us to install 25 cameras across their facilities. And in my computer, I have a continuous read of everything happening in that company, 24/7. And part of what they said is, well, what do you want to do with this information? So many years ago, when I'd gone to, many years ago, it was 2 years ago, when I went to visit them, one of the things I said is, well, you know, there's actually data in that camera feed. So what do you mean there's data in the camera feed? We're using it for security purposes. I said, no, you can actually collect data, and the data you can collect, as you can see, every time you see that rectangle, there's a piece of code running on the video stream that's counting. It's counting sheets being manufactured, people working, a material handling system, etc. In other words, this inexpensive $100 HD camera now becomes a data source. So what can this data source do for you? Well, a lot of things. So just those of you who want to know, we're using OpenCV, which is OpenCV code. There's a little Gaussian filter you can run, etc. Those of you who are interested, this is completely doable, and this is doable by master students who have fed this data. But what can you think about it? Every video device now becomes a data collection source. It allows you to get a time-stamped read of what is happening in the plant. Now, why is that important? Very often, when you look at archived data in company systems, this is data somebody has to input. Somebody punches a time card or enters a piece of data. Here, nobody is punching any time card. The video camera is automatically collecting this data, and actually it turns out that one video camera at this corner can collect a lot of data because you can do optical zoom to collect a lot of detail. So in one shot, you can collect a lot of information. So step one, that little video camera now becomes a very useful data source when you have a piece of code running on that videotape. Which also means I don't need to save that entire video camera information. I can save selected pieces of information, and I can just put it in a little spreadsheet if that's what we want. On the x-axis is time, on the y-axis is number of people. You can look at lots of measurements of productivity, yield, which job is being done. So step one, we can collect a lot of this information. Now, at this point, you might say, well, what are you going to do with this information? At this point, all you've done is connecting the video camera to get this information. It actually is very valuable when you have real-time information. And this gets to the question as to how do we convert the data that's collected into a business case for this company? So one thing is that this is a low-cost approach for this small company to collect information. But the way this company would compete is the speed of delivery. So this company had different sets of contracts. Contracts which had longer lead times and which were, the main focus was on low margin, deliver it at this date, I'll give you an order in advance. And then there are last minute, something is broken, I need it fixed, let's not talk about price, I need it immediately. Now the real money is made in coming to the rescue of a company when something is broken. Because at that time, there's no discussion regarding margin. But you need the rest of it to run your business. So part of the question is, if you have a good sense of where you are, you can estimate the cost impact of accepting this new order, knowing full well you have other work to do. In other words, one of the things that this company can do with this data is to figure out a better way to bid. And what I mean by that is keep track of the state of work in the company so that their salespeople can have a dynamic read of how to bid for the new work they can do. And this has a significant impact on profitability for this firm. So what started off as sort of a little example of deployment of video now evolves into a business case where it actually links to their company's system. They have little buttons for the margins they attach with respect to bids, and this data can now be related to those bids. So this is an example of a way real-time information can be deployed and used, and they can even be used by small, medium-sized firms. And all of this comes from HD cameras, which have GPS position, so we know exactly what is being collected. Now, how can we use this in a more general sense? And so the previous one was an example of what we're doing. This is a little aspirational. Remember, we professors sit in our office, we dream periodically of changing the world. Sometimes we do, most times we don't. And so one of the questions, you hear a lot about ethical supply chains. You hear a lot here in this industry, here. You see Apple's responsibility standard. Okay? And if you look at the standard, you get a detailed read of what suppliers are going to do. And very often, all you see is they hire an auditor who goes out and audits. But guess what? Why not have a camera installed in the supplier location? Why not run code on the camera that's positioned to measure exactly what is written in the contract so that you have a continuous monitoring of adherence to the contract? Okay? I actually don't understand why this hasn't already happened, other than the fact that people don't want it to happen, right? So a real question is, if you really cared about ethical practices, then you would deploy a solution that would continuously monitor so that rather than waiting for a failure, you would prevent the failure. In fact, why not set up a camera that will trigger whenever it sees a violation of something that was committed in the contract? In fact, you might start asking the question, which suppliers might agree to such monitoring? This is sort of a screening mechanism. The suppliers who agree to the monitoring are the suppliers who already adhere to the contract. And in fact, if you don't agree to the contract, you probably are worried about something. In fact, you might say, well, what if there are multiple clients sharing a line? so that I don't want you to monitor when other clients, well, that's what software can do. You just feed it when your job starts and ends. And so each person's contract can be monitored based on the terms that are already agreed to at the start. One of the things I wonder about is why this hasn't happened. And if any of you think you can build a system that can get this to happen and convince people, and if after that, if the big OEMs say they don't want to do it, you know why we don't see adherence to ethical supply chains. So that was an example of an extension from one example to another. Now I want to get you to think about on the retailing side. So let's think about potential customer sensing. One of the things that brick and mortar stores, before we write them off, let's remember that there are still malls existing. Maybe there are very few here, but in the rest of the country there are malls. So consider people walking past a store in the mall. Very often the showroom window is static. It's a bunch of displays. So one of the questions you might think about is, what could I do to make the showroom window more dynamic? And what I mean by dynamic is respond to the people walking by that showroom window right now. And in fact, could we also start communicating to people in the store window, we have a lot more stuff inside the store, and that might be related to what you might be interested in. So how might we do that? So I want to get you to look at now, if you just go to just do a search, there are lots of malls that give you live streaming of everything happening in the malls. They've just connected their video that they're collecting directly to the World Wide Web. So imagine there are all these people walking by. What can you do? It actually turns out that you can write a little parser that is operating on the data feed. So you can take each individual person, and the parser would break them up into the t-shirt they're wearing, the shirt they're wearing, the bag they're carrying, the shoes they're wearing, everything, for every individual person. So imagine as people walk by, you're getting a continuous read of what they're wearing, etc. What could you do with it? Well, you could connect it back to your back-end database of things you have, and you can feed this information to send, you can start figuring out what it is that people going by are wearing, what you have in your store that is related to what they're wearing, and you can push that out to showcase products you have inside the store. Now, one of the little secrets of retailing is that the most important step is to get the person inside your store. It's very difficult to get people to buy when they're not inside the store, unless they're on a smartphone. So the trick here is to find a way to showcase things and make the showroom window a lot more dynamic, reflective of the people walking in front of it. So if it turns out that there's a younger group of people walking by, the kinds of things you display might be very different than if you have families, older people, etc. So notice that here too, we've now moved from keeping track of things to proactively showcasing what we can do. And that's sort of the next step of one can potentially do. A third step is actually capturing customer input. And what do I mean by that? So very often when people go to stores, they ask questions. And you might say, hey, is this available or that available? And so you might ask, what happens to all those questions? More often than not, they just disappear. Nobody hears about them. So a good question is, what if these questions can be captured and shared? And so what might one do? So imagine that, and this is something, again, this is a product that doesn't exist. I've been telling my students to build it. Nobody has built it. Imagine that all the store personnel have a little, a little audio capture that gets triggered when there's a conversation. And that's GPS located. So as they walk around the store, people ask them questions. The data is captured. You can parse from audio to text, etc. So what are the kinds of questions? Somebody might say, oh, is this a jacket available in blue? Do you have this jacket with zippers instead of buttons? Do you have the shirt with narrower stripes, etc., etc.? These are questions being asked. So what happens to all these questions? You get a Boolean answer, yes, no. Well, what if you did the following? What if you statistically process all this information continuously? What might you do with it? Well, there's one company that uses this information, and that's Zara. At Zara, store personnel listen to the questions you ask, and at the end of the day, they send the information back to headquarters. A few years ago, we were on a visit to Galicia in Spain, and all the questions being asked are fed to designers who create a revised prototype, and they send it back to the store. Zara has the highest market capitalization in the apparel industry. Now, at Zara, all of this is done manually. Store personnel communicate customer feedback. Designers respond by making changes. Manufacturers make the product. These products are back in the store within 10 days. So here's the question. Why isn't this more widely available as a platform whereby questions that people ask in stores are mined, the data is mined systematically, and information is fed back to designers to make modifications? In this industry, there's a very large value to this change, and for some reason in this industry, this doesn't happen. I think of this as a wonderful opportunity. A quick example of something related to maintenance, I'm going to speed up this process a bit. And this is sort of a concrete example. This was several years ago with a colleague, Professor Vinayak Deshpande, and we were working with the US Coast Guard. And the specific question we were asking is, what can we do with data regarding use of products? And in this particular case, with aircraft parts, aging of the parts is related to flight hours accumulated on the part. So you really need to know how many flight hours did this part accumulate. And one of the questions we were asking there is, how can tracking of part age help estimating impending demand? Impending demand is demand for repaired products. That is, if you know in advance that this part is going to be repaired, you can be ready for it, so you don't need to have as many parts. I'm going to just show you this just because we're academics and we like quantitative data. And this is a particular data set fed to gearboxes from helicopters in the Coast Guard, where we looked at, can we fine-tune the sensor to give a high correlation between the signals we get and the correlation with observed demand. Because if you can get a good signal read, you can never get a perfect signal because you have to anticipate failure during the supplier lead time. But it turns out you can get a very high correlation. Now, what's the value? There's a paper to go with it if you're interested. What's the value of this signal? It turned out that this value of the signal was to decrease inventory cost by 18%. So there's actually a system implemented at the Coast Guard to actually get them to reduce their inventory so they can take signals from usage of the gearbox and feed it back to proactively manage inventory. So what I want to think about is that all of this is real because it can be converted into tangible numbers. And it's in these numbers that the value gets created. I want to just quickly talk about auto picking, and this is interesting for two reasons. First, many of you, if you just do a quick search on any search engine, you hear about augmented reality. And you hear, in the past year, you heard about Google Glasses. Well, those Google Glasses have a huge value in warehouses. Because if you think about warehouses, in warehouses, people are looking at orders that are being placed, they're reading the orders, picking items, etc. Well, it's a lot easier if you can feed this information directly for hands-free picking, or what's called vision picking. That means that the auto picker wears these glasses feed them information regarding what has to be done next. It guides them to where they have to go, which means no paper, no verification. It all happens much faster. And all of that has reduced the need for scanners, pack slips, verification, etc., all in one shot, because there's a lot of value that comes from here. So this is replacing the estimated benefit is about 25%. You can see examples from DHL Europe and others. Why are we interested in it? One of the things that we're doing, and this is a wonderful project, we got this opportunity to work with a nonprofit that's working with adults with developmental disabilities. And one of the issues is that you don't want to give them a whole bunch of data of what they should do. You want to be able to stream the next step, one step at a time. And so one of the things that we're looking at, and then this is an issue which has intellectually a very interesting flipping of the paradigm. Manufacturing was always somebody designed the process and stuck a bunch of people to do it. Here it's a little different. You think about the people doing it and their constraints, and you work back to figure out how should you create the manufacturing process to get this to work. I know that Amber is telling me I have 36 seconds. So one of the things we're trying to do is to convert tasks into what are called unit instructions and stream them to people. And as these unit instructions are streamed, you can actually get task verification, quality issues, etc. And I really think at the bottom end, technology can help these nonprofits and these small companies. So a few closing comments. This is my last slide. We think that we can learn about how these smart tools can generate productivity For us, there is a benefit to working on problems that students are involved in, and I can't resist putting a little plug for DSIMI, which is the Dauch Center for the Management of Manufacturing Enterprises, and we are the interface at Krannert that can welcome you to work with students. Thank you.